Now let's think about the scatter plot, which you're going to be using a lot. So that is a kind of graph where we're looking for correlation between two sets of continuous data. And so we're interested in the general trend and to do that we draw a line of best fit through the different data points. And we can use this to interpolate or extrapolate other numbers, which I'll explain in a second. Okay, so here we have independent and dependent data in pairs. Okay, so we're going to put our independent data on the x-axis and our dependent variable on the y. Now, so let's have a look at how to do our axes here. So here the independent goes from more or less 0 up to 2.3. 0, so you want this to go to 3 maybe. Let's divide that. Obviously you can do this better on proper graph paper. But now here the dependent variable, we only start at 1.7. So we don't need to go all the way down to 0. We can choose to start, so we're interested between about 1.5 and about 3. So let's do that. 1.5. Spread those out a bit more. 2, 2.5, 3. Okay, so for a scatter plot you don't need to start your axis at 0, that's important. Right, so let's just plot these. So we've got, I mean obviously I can't do this very well without graph paper, but that's going to be about here. Oops. This should have okay, so that is there 1.5, 2.0, no sorry, 2.5, 2.0 gives us 2.8, which is about here, and then 2.3 on the independent gives us 2.9, just a little bit higher. Okay, so there's all our different data points plotted, a bit wonkily, but never mind. And now I'm not going to join up every single point, I'm going to draw a line of best fit. So in this case these look about like a straight line, so I'm going to draw a straight line through them as best I can, and I'm trying to get half the points below the line and half the points above the line. So yeah, that looks pretty good to me. So that something like that. Obviously you can't do a perfect job, we're just going by eye, but the point is that they're more or less in a straight line and there's a positive correlation between the two variables. So as the dependent variable increases, so does, sorry, as the independent variable increases, so does the dependent variable. Now what I can do is this interpolate, extrapolate business. So interpolate is, for example, if I want to know what, for 2.25 on the dependent, what would I expect the independent value to be? So we just read off on the graph. So that would be about 1.2 probably. So this would be an interpolated data point. So independent sorry, I've written this wrong way around, 1.2, 2.25, something like that. And then if we extrapolate, then that's a number outside what we've got. So this would be if, now you've got to take it easy doing this, you can't do too well, too far away. But if we extended this line a little bit more, then and extend this a bit more, so let's imagine we want to know what 3.5 would give us. It's kind of like that. So that gives us something like 2.5. So that allows us to go further than our data, but you've got to be careful with that. So this is extrapolated. This is interpolated. And let's just label this up as, this line is the estimated line of best